Good morning, my dear students. So now I hope you understand about in the last three class what is the introduction about balancing, what are the importance of balancing, and what are the different types of balancing, and four different method, four different cases of balancing. Okay. Now in this class I'm going to solve the problems based on the four different cases what we studied in the last two class. That is the last two PPTs. Okay. So here in the first problem they may give one like this: a shaft carries a four masses, that is A, B, C, and D, of the magnitude of 200 kg, 300, and 400 and 200 kg respectively. Okay. Revolving at a radius of rotation is 80 mm, 70 mm, 60 mm, 80 mm in the plane measured from A at a 300 mm, 400 mm, 700 mm. Okay, the angle between the crank measured in anticlockwise direction, that is ACW means anticlockwise direction, or A to B, the angle of rotation is, that is the mass A to B is 45 degree, and mass B to C rotation angle is 70 degree, and mass C to D angle of rotation is 120 degree. They given. Okay, the balancing masses to be placed in a plane that is x and y. Okay, apart from those masses, again the balancing masses they given x and y at a distance of at a distance between the plane A and x is 100 mm. Okay. And for 100 mm between x and y is 400 mm, and between y and d is given 200 mm. Okay, if the balancing masses are rotated within radius of 100 mm, find their magnitude and the angular position. Okay, so here in the problem statement they given like this. So four masses are given. Okay, so that four masses are going to fix in particular shaft. Okay, that with an angular radius of the rotation radius also they given, and angle between the two different plane also given. But if you make it perfect balance one, their balancing masses are introduced, that is balancing, that is extra masses are introduced, that is x and y. We don't know the masses what they given, what we are going to fix, that you need to calculate from this given question. This is the meaning of this what the question. Okay, now how to solve here in the this balancing of rotating masses, you need to have the four data. So that is first one, you required the mass. Okay, and the radius of rotation you required, and angle theta is also you required. Okay, apart from that they may give the length also. Okay, so this is about the given data. So here in the from the read the question carefully, and the given data they may given mass of A is equal to 200 kg, mass of B is equal to 300 kg, and the mass of C is equal to 400 kg, mass of D is equal to 200 kg. Okay, along with the radius of rotation is also given 80 mm, 70 mm, 60 mm, 80 mm. Okay, RA, RB, RC, RD, and along with that they given the angle of rotation, that is angle of rotation, that is theta A to B is what 45, B to C is 70 degree, theta C to D is 120 degree. Okay, so that apart from that they given the length. Okay, A to X is 100 mm, and X to Y is given 400, and Y to D is given 200 mm, and we don't know the mass of X and we don't know the mass of Y. Okay, so Rx X and Y length is given 100 mm, we don't know theta X and theta Y. Okay, for calculate that we need to solve this problem. Okay, so here I show in the figure A and figure B. Figure A shows what the position of the plane, and figure B shows the space diagram here. Okay, so take the one particular shaft upon which the A, B, C, D mass are given mounted on a particular shaft. Okay, within radius of rotation is also given. Okay, so X and Y are the X balancing masses, they are introduced between, they are fixed in between A and B and C and D within distance of A to X is 100, and Y to D is given 200. Okay, so we don't know the X and Y magnitude, but we need to calculate, and also we don't know the angle of rotation between them. Okay, so this is about the explanation about the position of the plane diagram. And coming to the diagram B, so here the angular position they given, A to B angle is 45 and B to C is given. Okay, so these two diagram you need to sketch, rough sketch, not required, but you have to mention the accurate values, that is very important. Okay, so next how to solve this. Okay, so before starting this we need to require one reference plane. Okay, let us assume reference plane as an X. Okay, I mentioned here RP is nothing but reference plane. Okay, so if you assume reference plane means take the distance from that plane is 0, and while considering left hand side you are going to consider the length is negative, and right hand side values are positive length. Okay, so now what that is about the second step. Third step is you need to construct one 6 tabular column. Okay, so that is the plane, mass, radius, centrifugal force, distance from the reference plane, couple. Okay, these are the 6 column you need to form to solve this type of problems. Okay, so now planes are given A, X, B, C, Y, and D, write as it is. Okay, mass is also given, A mass is given 200, and mass of X we don't know, write it as it is, M of X. mass of B is given 300 and mass of C 400, mass of Y we do know, so mass of D is 200. Okay, radius of rotation in mass M, that is 0.08, that is they given in the radius of rotation they given in the mm, you need to convert here meter. Okay, so just divide by 1000 you are going to get. Okay, mass of A is equal to 0.08, so mass of X is given 0.1, 0.07, 0.06, 0.1, 0.08. so this is the given radius here. So here I shown here 80, 70, 60, 80, divided by 1000 you are going to get, that you write here. Okay, that you write in the tabular column. Okay, now centrifugal force, that is the fourth column, is m into our formula is there. Just to multiply 0.08 into this mass 200 is equal to, you are going to get 1.6, 0.1 mx, that is a 20, that is a 6, that is 200, 0.08, 16, 0.1 mx, 21, 24, 0.1 my, and 16. Just to multiply the mass into radius, whatever you are getting value, just to put it here. Okay, distance from a reference plane, that is the fifth column. How this is very important. So okay, distance from reference plane here I give here. So here reference is x, let us put right here 0 only. Okay, so 0 to A, so it is left hand side direction is there, 100 is there. Okay, so take the negative value from left hand side, you are going to consider the negative value, right hand side you are going to consider the positive value. Okay, so minus 0.1, so again x to, that is A to B is 0.2, again B to C is 0.3, 0.4, 0.6. Okay, so they are given according to the diagram, you have to write here. Again next one is couple polygon. Couple polygon is equal to, formula is there, m into r into l. Okay, so that you multiply this the mass, radius into length, that is 200 into 0.08 minus 0.1, you are going to get minus that is what, 1.6. Okay, so second one is, if you multiply anything means you are going to get 0 only. So third case is 4.2, so okay, 7.2, 0.04 my, so 9.6. Okay, so this is about the forming the tabular column. I hope you understand this forming the tabular column and values. Okay, so once you calculate that, you need to consider the couple polygon diagram and force polygon diagram. So look at here the couple polygon diagram, that is the fifth, sixth column. So here shown you 0, so 0 to A is minus 1.6 is there. Okay, take the graph sheet, assume take one point anywhere on the graph sheet. Okay, so 0 to A, so 0 to A is length is how much, minus 1.6 is there. Okay, so just to draw one minus 1.6, if it is not possible, it is in fraction also, you can convert the scale in graph sheet. Okay, so 0 to A is a minus 1.6. Again with okay, A to B is a height is, that is length is they given 4.2 with an angle of rotation A to B is 45 degree, they given here angle. Okay, so A to B angle is 45 degree. Okay, so keep protractor at point A, mark 45 angle with a length of 4.2, just to cut an arc, you are going to get a new point, that is B, and along with that you show the direction also, very important. Okay, from point B to C angle is given 70 degree. Okay, at point B keep protractor, okay, with a length of 7.2, cut one arc, you are going to get a new point, that is called as C. Okay, show the direction also. Okay, again C to D angle is given 120 degree, keep protractor at point C, measure 120 angle. Okay, with a length they given, cut it one arc. Okay, so after cutting this D point, so we don't have the next. Okay, so just you close that. Okay, just to join with a dotted line D to O. Okay, so once you finish this, so we have the formula, what, a distance of DO is equal to 0.04 my. This, okay, this the bracket square we are going to take there. Okay, so distance of DO is equal to 0.04 m. Our aim is to find the mass of Y. Okay, so distance of DO means take the scale and measure D to O. How much that you write here, you are going to get 7.4 something. So that is equal to 0.04. From that you are going to get mass of Y is equal to 185 kg. Okay, so this mass is going to fix in between that is last, that is C and D. Okay, so along with, and how to calculate theta Y, measure there, I shown in the diagram also, theta to y, if you measure that in anti-clockwise direction, you are going to get 349 degree. Otherwise, if you want to make clockwise, means in between that is a D to O, clockwise means you are going to get 11 degree. Okay, so at 11 degree at mass 185 we are going to fix on the particular shaft. So this is about the couple polygon diagram. Similarly, you find the force polygon diagram also. Okay, same diagram. So force polygon diagram means you take the values of centrifugal force, that is a fourth column. Okay, so 0 to A is 16 is there. Again same, take 0 to A, put one mark anywhere in the graph sheet. 0 to A length is one drawn horizontal line with a length of 16. Again point at A to B, measure an angle is 45 degree and length is 21, cut one arc, you are going to get a new point, that is about the point B. Okay, so at point B to C, again measure keep protractor at point B and measure the length that is say 24 and with an angle of 70 degree. Again you are going to get a new point that is C. Okay, again at point C you keep protected there. Again mark 120 degree, you are going to get a new point called D. Okay, C to D. Okay, again at D we calculated already this D to E. D to E is what you are this length. Okay, so 0 point you are going to get 185 kg and 39 D to O. So D to O you are going to get D to O that is 9.6 is there. Okay, that you 9.6 here you measure D to E. Okay, okay, D to, if you measure that you are going to get new point E. Okay, but we don't know the E to O, that you put dotted line. Okay, that is equal to 0.1 m into x. Okay, so how to find mass of x is equal to here, so distance of u to o is equal to 0.1 mx. Okay, from this m of x is equal to you are going to get 352 kg. Okay, and also how to measure theta x and theta y, other any you can take any one side, that is anti-clockwise direction or clockwise direction. If you measure the theta x you are going to get 2115 degree, or theta y is equal to 114 degree. Okay, so this is about the force polygon diagram and the couple polygon diagram. So unknown mass m of x and m of y. Okay, so I hope you understand this. Okay, just nothing but here in the I will write only 4 procedure. Read the question carefully, write the given data and construct the planar position and angular position and calculate this tabular column values and construct the force polygon diagram and couple polygon diagram. Okay, so this is about the first problem, and the second problem also same it is there. Okay, so here it is a little different than that one. Okay, so here I shown you here the second problem. I will read out the question. Okay, so a shaft running in a bearing, that is a shaft is running in a bearing, carries a masses of 20, 30 and 40 kg within center of gravity from the axis of the shaft, that is 30, 20 and 15 respectively. Okay, the distance of the plane B and C from A are 1000 and 2000 mm to the right of A. The relative angular position of the CG of the unbalanced masses are such that they are in static balance. Find these, that is to obtain a complete dynamic balance. Okay, so suitable masses are introduced in plane D and D with a center of gravity of 100 mm. From the axis D is 500 mm to the left of A to E is 500 mm to the right of C. Determine the position, find the magnitude and the balancing masses. Okay, so if you want to construct a force polygon diagram and couple polygon diagram, you require what, along with the mass, radius of rotation, length, angle is also very important. But here if you read this question, there is not given any angle, but you need to find out the angle first before starting the problem. Okay, so right here given data, so mass of A, mass of B, mass of C is given 20, 30, 40, and radius of rotation is also given A, B, C, D, that is 30, 20, 15. Okay, and along with that length is also given. A to C from A is 2000, B to C from A is 1000, and D to A 500 and E to C is 500. Okay, so in this problem the angle between the masses are not given. To find this angle of unit and construct a static force polygon diagram, that is a triangle. Okay, if you construct that, you are going to get the angle, so that we are going to solve the problem very easy. Okay, so these are different types. Okay, so how to calculate this A to B, construct the polygon diagram. Okay, 0 to A is given, that is a 0.6. Okay, 0 to A is given, the what here the angle is given 0 to A. So look at this 0 to A, 0 to A is 0.6 here they given the centrifugal force. Again B is also given 0.6, 0.6, 0.6. Okay, based on that you need to construct one triangle. Okay, 0 to A 0.6 and A to B is 0.6 is given, and B to C. Okay, angle is also given. Okay, 0 to A horizontal, A to B angle is 120, B to C is given 240. Okay, with a length of 0.6, 0.6, 0.6. Okay, angle between B and C, masses are made within masses A. Okay, so again same construct one what angle position of the plane and this angular position. Okay, so A that is here A, B, C. So these are the two masses are given, that you fixed on that. Okay, D and D going to fix with a length of 500. Okay, and this side also 500, and between A to C is 200, and A to B is 100. Okay, so based on this let us assume the D as a reference plane. From that point you are going to take the length of that particular shaft. So again figure B, again here also A, in between A to B a mass is introduced, that is E. Okay, so I shown here a dotted line, that you need to find the angle and what is the mass. Okay, same procedure you follow what you saw in the procedure. Again form a 6 tabular column. So plane A, and that is plane mass, radius, centrifugal force, distance from reference plane, couple. Okay, so here planes are given, that is a D, A, B, C, E. Okay, so mass are given, mass of D 20, 30, 40. Okay, mass of A is given 20, mass of B is given 30, mass of C is given 40, and E. Okay, so radius is given 0.1, 0.03. So that is in mm. You divide into 1000, you are going to get 0.1, 0.03, 0.02, 0.15, 0.1. Okay, centrifugal force is equal to what? Mass into radius. Okay, just to multiply this mass into radius, that is md into 0.1, you are going to get 0.1 md. Okay, like that 0.6, 0.6, 0.6, and this is, we don't know, that you need to calculate 0.1 into me. Okay, again distance from the reference plane, mass d, we are going to consider the reference plane 0, and the length of from that point is equal to 0.5, 1.5, 2.5, 3. So that is in mm. You divide in, that is you convert into meter. Again, last one is couple polygon, that is m into r into l. Okay, and this m into r into l is equal to what? Mass into radius into length. If you multiply that, you are going to get last value, that is md into 0.1 into 0, you are going to get 0. Again 20 into 0.03 into 0.5, you are going to get 0.3. like that you if you multiply means you are going to get last values. Okay, so this is the same couple polygon diagram and force polygon diagram. Again, from the couple polygon diagram, so take the last values, that is d to a 0.3 is there, so 0 to a 3 point. Again, keep protector at point A and measure angle 120 with a length of 0.9, that is you are going to get a new point B. Okay, again from point B to C, so measure the length and angle is 240 degree, you are going to get a new point C. Again, we don't know the length of C to O, just to put a close that one C to O with the help of dotted line. Okay, so now how to calculate this, how to calculate the mass of E, that is the distance of CO. Take scale. Okay, so C to E, C to O, you measure the length and 0.3 mu. Okay, so if you measure that, you are going to get 1.02 is equal to 0.3 mu. Okay, so you are going to get mass of E is equal to 3.4 kg. Okay, how to measure the angle theta E? Theta is equal to 32 degree, theta E is equal to 32 degree anti-clockwise direction if you measure from that scale. Okay, at point C to horizontal line. Okay, this is about the couple polygon diagram. So similarly, same procedure you follow the force polygon diagram. Again, take the values of force polygon to values from the tabular column. 0 to A is the 0.6. Okay, A to B length is 0.6, 120 degree angle. Okay, again you are going to get new point again. Okay, at point B to you measure it with an angle, what is angle of 30 degree, that we don't know, that is 0.1 mu. Okay, so again E to C, if you measure, that is the angle 240 degree. Okay, so you are going to get new point. C to O, we don't know, that you put it dotted line. Okay, so once you close that cycle, and that is close that one. Okay, you are going to measure the length of that C to O, that is the distance of CO, is equal to 0.1 md. Again, if from this equation you are going to get what? Md is equal to 3.6. Okay, so again if you measure that scale with the help of protractor, you are going to angle theta d is equal to 212 degree. Okay, so these md and theta d, me and theta e, if you perfect those masses, you're going to fix in place of that d and e, you are going to get what? The perfect balance one. Okay, so this is about the force polygon diagram and couple polygon diagram. Okay, so this is very very important problem. Okay, so they may ask you around 8 to 10 mark question. So okay, like that you are going to solve this type of problems. Okay, you have, unless you are not practicing, you are not getting you will not you will face the difficult. Okay, so reading is different, there is a procedure is different. Procedure looks like very easy, but if you if you practice means you are going to understand better than this reading this. Okay, so I hope you understand this. Okay, thank you. Okay, need to practice many more problems, any textbook. Okay, so I hope you understand this. Thank you.